All right, we're at the bottom of page 107, and this example has us using a calculator. So we're going to find the area of the region in quadrant 1 that is bound by these curves. So we are given y equals e to the 0.4x, y equals 2 cosine of x, and the y-axis. So in your y equals, make sure you're in radians mode. Go ahead and type those in. And we can't put the y-axis in our calculator because it's not a function, but we know what that looks like. And I'm going to just note on here that I'm putting this in y1 and this in y2. All right, so when we go to graph, and I'm just graphing under the Zoom 6, the standard -10 to 10 graph, we see that these curves intersect quite a few times. But we know that we're looking for the area that's in the first quadrant, and that's also bound by the y-axis. So let's just zoom in on this screenshot that I took of that graph. I don't know if you noticed, but I got an upgrade to my online graphing calculator. It's the newer operating system now. So this is our y-axis. We know that. And we're looking for the area in the first quadrant. We know this is quadrant 1. So when I look at the y-axis and then the two curves, I can see the top curve and my sine curve. When I move away from the axis, the bottom curve is my exponential, and I can see they intersect right here. So if I'm kind of keeping track of what I'm going to need to figure out in the calculator, I know my A value is 0. I'm going to need to figure out what my B value is. I know my top curve is going to be the cosine curve, and my bottom is going to be the exponential, because the region that I'm looking at is this little region right here. All right, so I'm going to go back to the calculator. And what I would do first is we've got to find that intersection. To make it a little easier to look at, I'm going to go from 0 to I don't know, 3. And then since we only need the first quadrant, I'm going to hit zoom fit. We've been out of school too long. I forgot all the shortcuts. Zoom 0, is that what I'm trying to hit? Oh my goodness, here it goes. All right, I'm just regraphing this so it's a little easier to see. So what we need to know is that intersection. So once this is done, we're gonna hit second trace to bring up that calculator menu, calculate menu. And we wanna go to 5 for intersect. And then we want to just get on this first curve as close as we can to that intersection. Hit enter. The second curve, it'll usually put it right there. Hit enter one more time, and then I usually just hit enter for guess. All right, so it's giving us the x coordinate of that intersection, and what I would do right now is store it. So don't move left or right, but go to second mode to quit, and then hit x equals, or x, and then enter. It's gonna be on that value we just had. We wanna store this. I'm gonna just store it as the letter A. All right. So, even though it's B, I'm going to call it A. All right, so we know that the area that we're looking for is going to be from 0 to that value that we just got. That's about 0.808. And we said that the top curve is, for that particular region, the top curve is the cosine curve. So 2 cosine of x. The bottom is e to the 4/10 x power. Now, we're not going to do this one by hand. Well, yeah, it would be awful to do by hand. So I'm going to recall that we stored the top one in y2 and the bottom in y1. So we're going to let the calculator do all of the math for us. Should always be that way, right? All right, so I stored that in A. So I'm going to go to math, and then I want the finite integral, so number 9. My lower limit is 0. My upper limit is that value that I stored in A. And then I want to do top minus bottom. And in my calculator, I stored the cosine value, the top value, in y2. So vars, y vars function, y2. And then the bottom one is in y1. So vars, y vars function, y1. And then it's with respect to x. And then hit enter. Let's see what it gives us. 0.491959 and so on. We want to take that out to at least 3 decimal places. 0.492. All right, and that's the area.